Hi guys, welcome to Dr. Zahir Math. In this video, I'm going to solve the exercise 2.3, which is the first order linear differential equations. If you like this video, please hit the subscribe button and tap the bell icon so that you will not miss the updates. So let's start. Exercise 2.3 linear equations. Why we learned this? That's first question. Linear differential equations, normally it comes in physics, engineering, economics, and many real-world applications. They help especially in modeling the electrical circuits, mechanical vibrations, population growth, and many more. And how to solve them is essential for engineering and applied sciences. So what is linear differential equation, which is the first order linear differential equation? So I already explained 1.1. What do you mean by linear and non-linear differential equation? Those who are not clear with this, please go and watch that video and come back to this video. Okay, right. So what is first order linear differential equation? dy by dx plus py is equal to q, right? Yes. So dy by dx plus py is equal to q, where p is a function of x. What do you mean by function of x? It means x is there. And q is a function of x. Right. This equation is linear. Why? Because the dependent variable y, yes, and the derivatives dy by dx appear in the first power. That means the power of this differential equation is what? 1. And the power of y is what? 1. Okay. So that's why this is called linear differential equations. So first power in the sense not squared, not cubed, and radical powers, whatever it is. Right. Now the question is how to solve this first order linear differential equation. Right. First thing is what? You need to identify the equation. What is the identification? So you should have dy by dx. After that, you should have p times u, which is equal to q, and that p is a function of x, and this q is a function of x. If this situation is there, then it's the first order linear differential equations. And what is its solution? The solution of this linear differential equation is given by, right, y times e to the power of integral p dx is equal to integral q e to the power of integral p dx dx plus c. It looks very lengthy. It's easy to remember. Look here, for this integral, this is the dx. For this integral, this is the dx. And for this integral, this is the dx. Finally, integrating constant c. Okay. So in the class itself, I told you, I'm going to solve this first order linear differential equation using 3 steps. What are the steps? This is your step number 1, right? And the whole thing, this is your step number 2, right? And everything all together, we are calling as step number 3. So total, we are going to use 3 steps to solve this first order differential equations, right? So once again, to repeat, the first order linear differential equation is dy by dx plus py is equal to q, and p is a function of x and q is also function of x. And its solution, for the variable separable method, we solve and we get the solution. But for first order linear differential equation, already the solution is ready and we are going to put the variables over there to get the final solution according to the given problem. So the solution is given by y e to the power of integral p dx is equal to integral q e to the power of integral p dx dx plus c. Right. Let's go to the first question. Right. So let's go to the first question. Right. So the first question in 2.3 is question number 5. Find the general solution. That means you are going to find out the general solution. Okay, right. So you are going to find out the general solution. Okay. The next thing, Find the largest interval. So this is the next question. Find the largest interval I over which the general solution is defined. So after you get this general solution, and based on that solution, you are going to define this largest interval, right? And determine whether any transient terms is there in the general solution. So interval, everybody knows this is called interval, right? And this is a new word. Electrical engineering students, they know what is transient terms. So for electrical engineering students, I'll tell you what is transient terms. Transients refers to the temporary behaviors in a system that occur when a system is subjected to a sudden change. What do you mean by that? Like a switch being turned on or off, or a change in a voltage or current, whatever you can take it. So these transient represents the system's response before it reaches a steady state. So what is this? Normally, what type of examples we can give for this transient terms? Of course, you know very well RC circuits, RL circuits and RLC circuits. What do you mean by RC circuits? Resistor, capacitor, circuit. What is RL circuit? Resistor, inductor circuit. And what do you mean by RLC circuits? Resistor, inductor, capacitor circuit. So where this transient terms applied in RC circuits? So let me tell you. When a capacitor is charged through a resistor, the voltage across the capacitor does not immediately jump to its final value. Instead of that, it increases gradually over time with an exponential decay in the transient phase before reaching a steady state. So there are two states are there. The final stage will be what? Steady state. In RL circuit, which is resistor inductor circuit, where this transient situation comes. So here, when a current is suddenly applied to an RL circuit, the current doesn't instantly reach its final value due to the inductor's opposition to changes in current. The current increases exponentially before stabilizing at a steady value. So where RLC circuits are? In a damped RLC circuit. You know what is damped, right? I told you in the class. In a damped RLC circuit, when the voltage is applied, the current in the beginning initially oscillates before eventually decaying to a steady value. That means what? The transient oscillations are due to the combination of the resistor, inductor and capacitor in the circuit. Okay, in which way these differential equations are connected to the circuits? Of course, the voltage, the current in these circuits can be modeled using differential equations. When a current is switched on or off, the solution to the differential equation often contains both transient terms and steady state terms. Okay teacher, where is the differential equations coming over here? Of course, the current equation everybody knows, right? The current equation is consists of what? Differential equation, right? So in this way, we are going to define transient term. Okay, this is a theory related to electrical engineering. But how we are going to find out the transient terms? How you are going to find out the transient term in mathematical way? So right, yes. So in mathematical way, if x tends to plus infinity or minus infinity, x tends to what? Plus infinity or minus infinity, automatically the part of the solution that fades away. What do you mean by fades away? That means it becomes negligible. That means it's almost tending to zero. So either you put x is equal to infinity, either x is equal to infinity or x is equal to minus infinity, automatically some particular terms in your final solution become zero. So those terms are called transient terms. Okay. So I'll solve this equation. Once the solution is ready, I will explain what is your largest interval and what is your transient terms. Okay. Right. Let's start this first order differential equation. Right. Y dash is nothing but dy by dx plus 3x square y is equal to x square. Clear everybody? Right. So now this is equal to dy by dx, right, plus py is equal to q. So what's your p? Just match this with your general equation. This is your p and this is your q, right? So p is equal to 3x square, right? And q is equal to x square. P is equal to what? 3x square and q is equal to what? X square, right? Yes. So what we are going to do? Now we are going to take the solution. What is your solution? Let me write here. Instead of going back, I will write here. So the solution is given by y e to the power of integral p dx is equal to integral q e to the power of integral p dx dx plus c. Okay, right. So I told you in the class itself, also in the beginning of the video, I said there are 3 steps. This is your step number 1, and in English we call it as, or mathematically you can call it as integrating factor we call. What do you call this one? Integrating factor. If you want, you can remember this, otherwise remember the solution only. And this is your step number 2, right? And the whole thing we are going to find out as step number 3. There are 3 steps. Okay, let me go to the first step. Step number 1. Step number 1 is, which is in e to the power of integral p dx, which is equal to e to the power of integral. Okay, what's your p? Your p is 3x square dx. This is equal to e to the power of 3 will come out integral x square dx. This equals e to the power of 3. X square integration is x cube by 3. 3 gets cancelled. So this is e to the power of x cube. Okay, this is what? E to the power of x cube. Let's go to step number 2. So we'll go to step number 2, right? I'll use another color, right? Step number 2 is integral q e to the power of integral p dx and dx. I'm not going to put c now. Later I'll put it c. Okay, I'll put the value, put c, right? So this equals, this already we got it by step number 1, right? So what's your q? Your q is x square. So this equals integral q is x square, and by step number 1 we got it as what? E power x cube, right? Into dx. Okay, now what happens? 2 functions are in the product. Either you should use integration by parts, or the best way is what? Substitution method. Okay, so let's go with substitution method. Put x cube is equal to t, right? Yes. Then after that we are going to differentiate this one. What is that? Dt by dx we are going to do. What is dt by dx? Which is 3x square. Look at the equation and try to convert everything in terms of what? T, right? So let's see here. We have x square, we have dx is there, right? So here also we have x square is there, we have dx is there. So x square dx is equal to dt. I'll take this 3 to the down. So dt divided by 3. So what happens to your equation? This one. So this x square dx will be what? Your dt divided by what? 3. And this e power x square becomes e power t. So this equals integral e power t and dt divided by 3. So this 1 by 3 will come out. Integral of e power t is e power t. Is this your answer? No. We are going to substitute the value of t. So 1 by 3 bracket open e to the power of x cube, because t is what? X cube. T is what? X cube, right? Okay. So we got step number 2 is 1 by 3 e to the power of x cube, right? Let's go to step number 3. So what is your step number 3? I told you the whole solution will be your step number 3. So y e to the power of integral p dx is equal to integral q e to the power of integral p dx into dx plus c. Okay, right. So I said this is step number 1, including integration step number 2. Keep in your mind. So y e to the power of integral p dx. This is your step number 1, e to the power of x cube. So this is e to the power of x cube, which is equal to the whole thing just now we got. This is step number 2. This is 1 by 3 e to the power of x power 3. So integration is over, plus integrating constant c. Right. Now I told you most of the time, not most of the time, almost all the questions, right? We are going to give the solution is what? Y is equal to. So what happens now? I need to give y is equal to. So it means what? I have to divide by e power x cube. I have to divide by e power x cube, and I have to divide by e power x cube. So what happens now? This is equal to y, and this e power x cube gets cancelled. Okay, right. So when it gets cancelled, what is your term? Which is 1 by 3 plus c e to the power of minus x cube. How? Because I'm taking this e power x cube to the top. Look here, e power x 1 by, when it comes to the top, which is e power minus x. Suppose you have 1 by e power minus x. If you bring it to the numerator, it will be e power x. Okay. So this is going to be your solution. Y equals 1 by 3 plus c e power minus x cube. Right. Now we are going to discuss the things. This is your solution. Finished. This is your general solution, right? So in the general solution, you're going to discuss two things. Number one is your largest interval. Your number one is what? Your largest interval you're going to discuss. And the second thing is what? You're going to discuss about the transient term. You're going to discuss about what? Transient term, right? Let me discuss about the largest interval, okay? Right. So what do you mean by largest interval? Interval you know very well. This is the line when I draw this one. This is called interval, right? It goes from minus infinity to plus infinity, right? Yes. Now look at the terms here. There are two terms. What are they? 1 by 3 we have, and this term we have, right? 1 by 3 of course a constant term. It's nothing but the constant voltage in the circuit, right? Yes. So the remaining thing is what? You have c e power minus x to the power of 3. Remaining things what you have? C e power minus x to the power, c e power minus x cube. You can say x power 3. What did I say? The definition of the transient term and the largest interval. The largest interval you need to pick up from the interval values. The transient term I said when x goes to or x tends to either plus infinity, okay, either, or minus infinity, okay. And the term must become 0. If the term vanishes to 0, then that term is called transient term. That term is called what? Transient term. I just gave you, I told you all the ideas about the ideas which applied in the electrical circuits, right? Now look back here, right? So what happened to this now? We are going to think about the terms, which is the interval. So how we are going to discuss about the interval? Just you see that the function which is here is what? E power. The function is what? E power. So e power is nothing but what? Exponential functions. So we know very well all the exponential functions are defined for only all real values. That means what? Real values means what? Starting all the values here, right? Because of the exponential functions. So what about all the real values? It means what? It is going to become what? Minus infinity to plus infinity. So this is your largest interval. Okay, right. So largest interval means what? This one. Why? Because e power minus x cube is defined only for real numbers, or you can say simply real values, right? Yes. Let's go to the transient term. There is one term here, c e power minus x to the power of 3, right? Yes. Now what happens? You just put either x goes to infinity or x goes to minus infinity. What happens now? Automatically it becomes, if you take x equals infinity here, e power minus infinity is going to become what? 0. Teacher, e power infinity is infinity. I said either one value, either infinity or minus infinity. That particular term vanishes to 0. So automatically when I put this one, I'm getting 0. So therefore your transient term in this, your transient term in this question is, right, c e power minus x cube. Okay. And your largest interval is what? Your largest interval is what? Minus infinity comma plus infinity. Okay. So I think I explained almost something with transient terms, everything related to electrical engineering, which I said the same thing in the class itself, right? Okay. Now we'll go to the next question. Right. Let's go to the next question. Solve the initial value problem. X plus 1 is equal to dy by x plus 1 dy by dx is equal plus y is equal to ln x. Y of 1 is equal to 0. When this condition is given, you are going to find the value of what? C. And in this question, they are asking, give the largest interval I over which the solution is defined. So they are asking only the largest interval. They are not asking what? The transient term. But still, I will explain about the transient term in this equation. Okay, nothing wrong in that. So, okay. So let's start the question. Okay, right. So what is the question? Let's go to the solution, right? Yes. The solution is, right, x plus 1 dy by dx, okay, plus y is equal to ln x. Okay, teacher, is it a first order differential equation? Yes. Because why? Because it is dy by dx, so it is first order. Okay. And y is power what? 1. And dy by the whole power is what? Dy by dx whole power 1. So it is first order linear differential equation. So we are talking about first order linear differential equation, which is of the model dy by dx plus py is equal to what? Q. And p is a function of what? X. Q is a function of what? X. Keep in your mind. The previous question also, all functions of x. I can show you also. Just see here. This is a function of x and this is a function of x, right? P is equal to 3x square there. Okay, so it's a function of x. Now look here. So first, look at your question. Is it in the form of correct exactly like this? No. Look at here. Some terms over here, it is not, the coefficient is 1. But here the coefficient is what? 1. So first we need to bring it to this model. So how we are going to bring it to this model? Very simple. We are going to divide x plus 1. We are going to divide x plus 1. And we are going to divide x plus 1. Right? So what happens to the differential equation now? Your differential equation is dy by dx plus 1 by x plus 1 y, which is equal to ln x divided by x plus 1. How, teacher? This is 1 by, you should write y by, I already told you, if it is y by 2, we can write 1 by 2 y we can write. So because 1 by 2 is multiplying with y. So the same manner, I am writing 1 by x plus 1, okay, and then times y. Okay, right. Yes. Now let's start. So this is of the model. Now dy by dx, okay, plus py is equal to what? Q. So what's your p? Your p is 1 divided by x plus 1. And what's your q? ln x divided by x plus 1. Look, p is a function of x. Yes. Q is a function of x. Yes. What do you mean by function, teacher? See, look here, all x. Look here, all x. So your p is equal to 1 over x plus 1 and your q is equal to ln x over nx plus 1. Clear? Right. So how we are going to do this one? We have the solution already. What is the solution? The solution is, right, the solution for this first order differential equation is y e to the power of integral p dx is equal to integral q e to the power of integral p dx dx plus c. Teacher, do I need to remember this rule? Yes, yes, yes. You have to remember this rule. We will not give you anything in the question. So you have to memorize this rule. Solution you have to memorize. Okay, right. So how many steps in this question I said? There are 3 steps. This is your step number 1, which is integrating factor. And this is your step number 2, right? And the step number 3 is the whole question is your step number 3. Here we need to find the C. Be careful. Why? Because you have the condition y of 1 is equal to what? 10. So we should be very careful when there is a condition is available. We need to find this C. Okay, right. So let's start step number 1, right? Step number 1 is what? Step number 1, which is e to the power of integral p dx, which is equal to e to the power of integral, right? What is your p? Which is 1 divided by x plus 1 into dx. We did this type of integration many times. Always you close this your finger with e. Close it like this. Only you do the integration on the top. Okay, yeah? Right. E to the power of dx divided by 1 by x plus 1 is ln x plus 1. ln x plus 1. After that, you need to remember one rule which you studied in calculus 3. E power ln a is equal to a. In multiple integrals, we use this rule in many places. So what do you mean by that? E power ln 2, which is equal to 2. You can also check in the calculator. The same answer will come. Okay, yeah, right. So this equals, this is your a. So e power ln a is equal to, what is the answer? Which is equal to what? A. So what happens to your equation? Your equation is a is equal to what? X plus 1. So this is your step number 1. Again I'll repeat. E power ln x plus 1. So e power ln a, this is your rule. Okay, yeah. E power ln a is equal to what? A. So your a is x plus 1. So the same x plus 1 has got it because e power ln a is a. Now let's go to step number 2. What is step number 2? Integral q e to the power of integral p dx dx plus c. So okay, c I'm not going to take it now. Let us remove it now, which is equal to, this is from the step number 1. Okay, right. So integral q. What's your q? Let me go here. ln x divided by x plus 1. So this is ln x divided by x plus 1, and this is from the step number 1. We got x plus 1 into dx. This is equal to x plus 1 cancels together, all cancels. So you get what? Integral ln x dx. I already told you, please remember this integration formula. What is the integral of ln x dx? Which is equal to x ln x minus what? X. So this is x ln x minus x is your integration answer, right? So step, of course, plus c is there, but we are not using it. We are using it in the final solution. So let's go to step number 3, right? So when I go to step number 3, what is my step number 3? The whole solution is your step number 3. So y e to the power of integral p dx is equal to integral q e to the power of integral p dx dx plus c. So this implies y, this is from step number 1, which is here, which is x plus 1, which is equal to integral. This is step number 2. There is no integral. All together we did it. This is step number 2. So this is x ln x minus x, okay, plus c. So I told you, you have to give the answer y is equal to. So what I'm going to do, I'm going to divide by x plus 1. I'm going to divide by x plus 1. I'm going to divide by x plus 1. And I'm going to divide by x plus 1. Okay, right. So this equals y equals x ln x over x plus 1 minus x divided by x plus 1 plus c divided by x plus 1. So this is your final answer before finding c, okay, of the solution, general solution. So now what we are going to do, we are going to find the c. So we are going to find c, right? So to find c, we need to use the condition. What is the condition given? Let me go to the question and I'll find out. Y of 1 is equal to 10. So which is y of 1 is equal to 10. Which means what? Y equals 10 and x equals what? This is your x. X equals 1. Right. Let's start now. So in this equation, I'm going to put the value. Okay. Right. So y equals 10, which is equal to x equals 1 ln 1 divided by 1 plus 1 minus 1 divided by 1 plus 1 plus c divided by 1 plus 1. So 10 equals ln, you put in the calculator, ln is equal to what? 0. So this is going to become what? 0, right? This is going to become 0. Are you sure? Yes. Because even though you get 1 by 2, ln 1 is what? 0. minus this is going to become 1 divided by 2, right? Sorry, let me write again. 1 divided by 2, okay, right, and plus c divided by 2, right? Okay, so you can do it with the calculator or whatever it is, any one way you can do it, okay, yeah, right. So what happens now, which is going to be simplified, this 10, I'm going to take it this half here. So 10 plus half, which is equal to c by 2. You can use calculator, no problem. This is twice times 20. 20 plus 1 is 21 divided by 2, which is equal to c by 2. You can cancel 2. Any method you can use, no problem. C is equal to 21. Right, what we need to do, I have to go back to the equation. This is my equation. In this equation, I have to put the value what? C, right? So y equals, so my general solution is, I'm going to write the general solution. So my general solution is y equals x divided by x plus 1 ln x. Let me see it again. Minus x divided by x plus 1, okay, right? And then after that c divided by x plus 1. So c divided by x plus 1. So this c, I'm going to put it as 21. So this equals y divided by x plus 1 ln x, okay, minus, right, x divided by x plus 1, right, plus 21 divided by x plus 1, okay, right. So this is going to become your solution. This is going to become what? Your solution, right. Now we have only one question, extra question. What is that? You are going to find out the largest interval. Largest interval means which is defined on the real line. That is the interval, okay, right. So what I'm going to do, I'm going to find out the same real line. Last problem I said e powers. E powers, I said it is defined for what? All real numbers, I said. E power what I said? It is defined for what? All real numbers, I said. But here you look, all of you, we have ln x is there, and we have x plus 1, x plus 1, x plus 1 is there, right? Suppose I put x plus 1 is equal to 0, right? So what I will get? X equals what? Minus 1. So this means what? We are going to see that. So what we can do, ln x also, this ln x we can say it is only defined for x greater than 0. Why? Because ln of minus 1, you just put in the calculator, you will get error. So it's not defined. Ln of minus 2, you put in the calculator, you will get error, not defined. So it means final conclusion is ln x is defined only for x more than 0. X is more than what? 0. So ln is only valid, ln of x is only valid when x is what? More than 0, right? And also this solution is valid where the denominator x plus 1 is not 0. That means what? X not equal to minus 1, right? So and also the ln x is defined for x more than 0. So altogether if you combine, so your largest interval will be 0 to infinity. Negative values will not come. So it is defined over I. So I is equal to 0 comma infinity, right? That's all your question. But in the last question, they discuss about the transient terms, right? Last question what? They discuss about transient term. But in this question, there is no transient term. You read the question carefully. They are just asking the largest interval only. So for example, let's say what will be your transient term in this question. Suppose, what did I say about transient term? Your transient term means, your transient term will be what? When x goes to infinity or x goes to minus infinity. If the particular term becomes 0, then automatically that will be a transient term, right? So you look here, first one, here there is a x here and there is a x plus 1 here. You put infinity here, infinity by infinity, okay? So cancels, so you're not going to 0. Here also you're not going to 0. But you look here, 21 divided by x plus 1. Can you see this term? 21 divided by x plus 1. Can you see that? So if I put x goes to infinity here, automatically this term tends to what? 0. So therefore, the transient term or the term is transient as it decays. You can say decays, also technical word, you can say decays to 0 over time. It means what? It vanishes as x increases. That's a simple meaning, right? So, but these two terms does not decay, right? Does not becoming 0, right? So only term is 21 divided by x plus 1 is indeed a transient term. The remaining part is there, but it is not transient. Okay. So in this way, the solution contains only one transient term, which is 21 divided by x plus 1, which I already told in the class, right? Yes. Now that's all. Your 10 point, what is the exercise number? Your exercise number is 2.3, right? Which is first order differential equation is done. Clear all of you, everybody? Right. So that's all for today's lecture. So please keep watching regularly and just keep writing also. Practice it. So once you practice only, you are able to solve differential equation. Keep this in your mind. Keep learning. Take care. Bye-bye.